This video, we're going to review Precalculus Part 1 called College Algebra places. It's going to review mostly functions, domain, range, interval notation, increasing, decreasing, finding x-intercepts or zeros, rational root theorem, things like that. So we're not going to do any trigonometry in this one. That'll be in our next video in the trigonometry review. That's Precalculus Part 2. Starting off here, we're going to find f of -9 when f of x is equal to the absolute value of x minus 6. So f of -9 is going to be absolute value of -9 minus 6. Is 9 minus 6 is going to be 3. That means that there's a point on the graph, -9, 3. Now we're going to find f of 0 when f of x is equal to the square root of x squared plus 9x. F of 0 is going to be equal to the square root of 0 squared plus 9 times 0. That's going to be 0 plus 0. The square root of 0 is 0, so that means that there's a point 0, 0 that's on the graph. Third, we're going to find f of -x when f of x is equal to x over x squared plus 2. F of -x is going to help us determine whether the function is even, odd, or neither. So this is -x over -x squared plus 2. I jumped ahead and didn't put that negative there. A negative times a negative is a positive. Because this is exactly the opposite of my original function here, that means that this function is what we call an odd function, because f of -x is equal to -f of x. That's what makes it odd. If it had been even functions are when f of -x is equal to the original f of x. That's going to be an even function. We're going to be asking a little bit to determine whether a function is even, odd, or neither. That's how we're going to do it. Now we're going to take -1 times the original function. So we're just going to change the sign of everything. So -f of x is going to be a negative absolute value of x minus 6. Watch out for the difference between a -x and a negative y. This is the negative y value. So now we're going to stick in an expression in the place of x when f of x is equal to x squared minus 8 over x plus 5. We're going to stick in x plus 1, which is going to be a transformation of this function. That's going to be shifting the function 1 to the left. So x plus 1 squared minus 8 over x plus 1 plus 5. F of x plus 1 is going to be x squared plus 2x plus 1 minus 8 over x plus 6 is x squared plus 2x minus 7 over x plus 6. Come on back up here. Now we're going to do another type of transformation. This is going to be a horizontal compression. F of x is going to be equal to -2x squared plus 3x plus 3. And we're going to replace x with 2x. So that's -2 times 2x squared plus 3 times 2x plus 3. We're making everything happening with y happen 2 times faster. So the graph is compressing horizontally. -2 times 4x squared plus 3 times 2x plus 3 is -8x squared plus 6x plus 3. Now we're going to do an important type of composition of functions here that we're going to use with something called a difference quotient later. We have to learn how to find f of x plus h, or I'm going to show you that typically we're going to call that f of x plus a delta x in calculus, but it's the same thing. So our f of x is equal to 5x plus 3 over 7x minus 2. Give myself a little bit more space here. F of x plus h is going to be 5 times x plus h plus 3 over 7 times x plus h minus 2. So that's going to be equal to 5x plus 5h plus 3 over 7x plus 7h minus 2. We'll be doing some more of that with some difference quotients here in a little bit, because there's going to be a formula that's going to say f of x plus h minus f of x, all divided by h, that is a slope formula, and we'll find that difference quotient here. Now we're going to look at some graphs and interpret them. We're going to find f of negative 0.9, negative 9/10. So it is right here. The ordered pair is right there. So f of negative 0.9 is going to be equal to 2.641. The ordered pair is on the graph right there. Next, we're going to look at the graph and find f of 0. So f of 0 on this graph is going to be equal to 2, because the ordered pair is 0, 2 is on the graph. Now we're going to have to do some work on this one. F of x is equal to x minus capital B over x minus capital A. And they tell us that f of 8 is equal to 0. And f of 9 equals undefined, right? So that means that there's a 0 in the top of the fraction here for 8. So that would tell me that this is x minus 8. And f of 9 tells me that there is a 0 in the bottom of the fraction when it's undefined. So that's going to be x minus 9 in the bottom. So this is just realizing that you get 0 when the numerator is 0 for a fraction, and you get undefined when there's a 0 in the denominator. That's all that that is. All right. Now we're going to determine the domain and range of this relation. That's a set of ordered pairs. So we have -2, -8 as an ordered pair. We have -5, 7 as an ordered pair. We have 10, -9 as an ordered pair. We have 3, 2 as an ordered pair. And we have 12, 4 as an ordered pair. So my domain is going to be the set of all my input values. I'm going to list them from lowest to highest. So -5, -2, 3, 10, and 12. My range is going to be my set of output values. Again, I'm going to list them lowest to highest. -9, -8, 2, 4, and 7. Does not necessarily mean that -5 goes with -9, -2 goes with -8, and so on. These are just all the valid inputs. These are all the valid outputs. I would have to actually look at the graph to see how the ordered pairs are ordered together. Sometimes more than one input goes with the same output. So you cannot assume that the ordered pairs match like this. All right. Find the domain of the function f of x is equal to x squared over x squared plus 6. We've got 3 rules. Since we're in precalculus, we've got 3 rules. I was going to say 2, but there's 3 rules. Don't divide by 0. Which we just talked about. Don't take even roots of negative numbers. And 3, only the base and argument of a log must be positive. We'll get to logs in a little bit there towards the end of this worksheet. But for right now, we're going to be dealing with these two rules. So we're going to look, can we divide by 0? Is x squared plus 6 ever equal to 0? Well, that's not a problem. X squared is never equal to -6. I don't square a number in the real world and get a negative. So that's not a problem. I don't see any square roots in the problem. So the domain for this problem is going to be all real numbers, which I'm going to express in interval notation as -infinity to infinity. I could also express it as all real numbers, which is an R. Let me come back here, which is an R with a little line next to it. If we could do this in boldface type, we would make it a capital R that was bold, that would represent all real numbers. Okay. Number 13, we have h of x is equal to x minus 4 over x cubed minus 4x. We're going to have to factor that denominator to find the domain. X minus 4, x times x squared minus 4 is going to be x minus 4 over x times x plus 2 times x minus 2. That numerator doesn't bother me. It's only the denominator that bothers me. X can't be equal to 0. X can't be equal to -2. X can't be equal to 2. I'm going to skip solving for all the zeros in the denominator because I can look at them and get 0. We solved for those the past couple videos. I think at this point you can probably look at that and say this factor becomes 0 when it's 0. This factor becomes 0 when x is -2. This factor becomes 0 when x is 2. Show your work if your teacher makes you show your work though. So my domain is going to exclude those numbers from the number line. There's 0. There's -2 and there's 2. I'm not going to show this all the time either. I'm just reviewing how we used a number line last time to find the domain like this. So this is -infinity to -2, union -2 to 0, union 0 to 2, union 2 to infinity. So because I have 3 bad points, I'm going to have 4 intervals here. Now we're going to go on to that second rule that I told you about square roots or 4th roots or 6th roots or any other even root. This is a square root though. The index is invisible. We don't write it. We assume that it's a 2 right there. So it's an even number. So I can't have a negative on the inside, but so I can have a positive or I can have a 0. Negative x needs to be greater than or equal to -14. When I divide by -1, I change the direction of the inequality sign. X has to be less than or equal to 14. Here's 14. Here's equal to 14. There's less than 14. So this is -infinity to 14. And that upper bound is included. Now I'm going to have a problem where I have to consider both things because I have a square root in the denominator. So normally I would say that the denominator or the inside of the square root has to be greater than or equal to 0, but it's not allowed to be equal to 0 here because it's in the denominator. So I'm just going to say strictly greater than, and I'm going to add 9 to both sides, and x has to be greater than 9. So if we put that on a number line, there's 9 with an open circle, and greater than is going to be 9 to infinity. We have a graph of a function given, and we're supposed to answer if f of 20 is positive or negative. F of 20 is in this interval, right? Let's look, 1, 2, 3, 4, 5. So each tick mark is 5. F of 20 is at the 4th tick mark. It's where that dot is. So f of 20 is going to be greater than 0. It's positive. It's above the x-axis. For what numbers is f of x equal to 0 for the graph for number 17? So again, we got to look at tick marks here. 1, 2, 3, 4, 5. So each tick mark is worth 4. So we've got -12. We have that is 12, and a little bit more is maybe, that looks like halfway between. So that looks like 14. And then that looks like 20. Okay. So that looks like my zeros of my function, all my places, all my x values for which f of x is equal to 0. For what numbers for the graph? Same graph, actually different scale, but basically the same graph with a different scale. For what numbers of x is f of x greater than 0? So we're going to start off with, we're going to do this in interval notation now. It's going to start off here at the point where x is -5. See that point right there? That's included because it's positive there. We're going to go down to -3. -3 is not going to be included because it's a 0, so it can't be greater than 0 there. And then we're going to have a union. We're going to come back here to, that looks like 3.5, where it's a 0. And then we're going to stop at 5, where it's 0. We're not including the zeros because the zeros are not greater than 0. We're only including the regions where it's above the x-axis. Now we're going to answer what is the domain of f. Again, same graph, but we've changed the scale here. So the domain is going to start at -50, and it's going to go all the way to the right to +50, and both are included because there's ordered pairs there. Now we're going to find the x-intercepts of this graph. And again, same graph, but we've changed the scale here. So 1, 2, 3, 4, 5, we're back to the original question, but x-intercepts are points on the graph. They're not just the zeros, right? So I'm going to take those zeros that I had before, where I said I had -12, and then I had, I think it was 14, and I had 20. And I'm going to have to change those to ordered pairs. So it's going to be -12, 0. Then I'm going to have 14, 0, and I'm going to have 20, 0. Make sure if your teacher asks you for an x-intercept or a y-intercept, you answer as an ordered pair because intercepts are points on the curve. What is the y-intercept? The y-intercept, there's only going to be one of them, is when x is 0 and y is going to be -15. This graph. How often does the line y equals -5 intersect the graph? So we're gonna just take a look here. Looks like we have y equals -5 is down here. You see that? And it looks like the answer is never, right? Never, because it looks like all y values, all range values are greater than -5, always. So now we're going to look at number 23, for which values of x does f of x equal to 40? So we are looking here at this tick mark right here. And we know for sure that it's 40 where that dot is right there. And that's at this x value, which is at 80. So we know for sure that it's at 80. We would think that it's also somewhere over here between -60 and -80, but that's not an option. So 80 is the only ordered pair that we see. There's somewhere else over here that is between 80 and 100, maybe 90, but that's not an option either. So given the function f of x is equal to 3x squared plus 6x plus 9, is the point -1, 6 on the graph? Well, let's find out. F of -1 is equal to 3 times -1 squared plus 6 times -1 plus 9. I'll show you a different way to evaluate this in just a second. 3 times 1 minus 6 plus 9 is 3 plus -6 plus 9 is 3 is going to be 6. So that means the point -1, 6 is on the graph. We can also evaluate functions with what we call synthetic division. So if I have -1 is the x value that I want to evaluate it at, I'm just going to write down the coefficients, all the coefficients, even if there's coefficients of 0. I don't want to skip any powers of x. I'm going to bring down, then multiply and add, and multiply and add. And this right here is my function value. And I was interested, was f of -1 equal to 6? And it was. Given the function f of x is equal to 7x squared minus 14x plus 4, is if f of x equals 1, what is f of x? So 7x, if x equals 1, what is f of x? Well, I'm going to use synthetic division. So if x equals 1, 7, -14, 4, 7, 7, -7, -7, -3, f of 1 equals -3. What is the point on the graph? 1, -3. So you'll catch that. They gave me the rule. They gave me an x value to evaluate it at. I can stick it in if I want to, that's 7 minus 14 plus 4. 7 minus 14 is -7. -7 plus 4 is -3. I get the same answer. Let's move on to number 26, and it looks like we're about to do a difference quotient. So difference quotient, just so you understand the concept of what it is, that there's a horizontal distance here between these 2 points called h. We're calling this first point x, f of x. We're calling this second point over here x plus h because we've gone a horizontal distance away, f of x plus h. And if we wanted to find the slope of the line formed by these 2 points, it would be y2 minus y1 over x2 minus x1, and x minus x would become 0. F of x plus h minus f of x over h. We would have the restriction that h could not be equal to 0 because we're not allowed to divide by 0. So we're going to do that here. F of x is going to be equal to 5x minus 7. From what I just told you about what this difference quotient is and how it finds the slope, you know that this is the slope of a line. Right here, y equals mx plus b, we should expect that the answer to this question is going to be 5 because it's sitting right there in front of us. But let's prove that. If we have f of x plus h minus f of x over h, that's going to be 5 times x plus h minus 7 minus the original 5x minus 7, all divided by h. That's going to be 5x plus 5h minus 7 minus 5x plus 7 all over h. All the things without h's are going to go to 0. And we're going to be left with 5h over h. Remember that h is not allowed to be 0. So because h is not 0, this is not 0 over 0, it's a non-zero number over itself, I'm allowed to cancel it out to make a 1, and my answer is 5, just like I expected it to be. For number 27, f of x is going to be quadratic now, x squared plus 2x minus 4. I'm going to stop and I'm going to show you Pascal's triangle to deal with polynomials like this now. Let's start with a 1 in the top, bring down the 1s. 1 plus 1 is 2. Down that 1, 1, 3, 3, 1. Each time I'm bringing down the 1s. And then if I can add, I add and get the next row. So this next row would be 1, 4, 6, 4, 1, and so on. And you can keep making Pascal's triangle as big as you want to. Why do we need to know Pascal's triangle? Because it's going to give us the coefficients of x plus h to the nth power, where this starts with n equals 0, n equals 1, n equals 2, n equals 3, n equals 4, and so on. This time we have x plus h squared in the problem. So it's going to be a 1x squared plus 2xh plus 1h squared, or we just write that as x squared plus 2xh plus h squared. You could write hx if you wanted to. I'm just writing my x's first because they appear first in the factor that is being squared that we were shown here. So f of x plus h minus f of x divided by h in this problem is going to be x squared plus 2xh plus h squared plus 2x plus 2h minus 4 minus my original of minus, so that's going to be minus x squared minus 2x plus 4, all that divided by h. All I did with my subtraction at the end was change every sign in my original. Everything without an h in it should cancel, or not cancel, should zero out. Again, that's all the things that are in the f of x over here need to go away, so that I'm only left with the terms that have an h in them in the original. I have a common factor of h that's going to factor out now, 2x plus h plus 2 over h. Remember, h is not equal to 0, so I'm allowed to make this cancellation here. I'm left with 2x plus h plus 2. That tells me that this slope at any point on the quadratic is not just based off of the x value, but its slope is going to be based off of how far away I get for that second point. That the further I get away from that, the steeper the slope of the secant line is going to be. And we can understand that because it doesn't grow at a constant rate, that if I get close to that line, that's less of a slope than if I get further away. So that all makes sense to me. Okay. The difference quotient is going to be the slope of your secant line, or your average rate of change. Number 28, f of x is going to be 1 over 4x. So this is going to be a little different because we're going to have to make a common denominator here. F of x plus h minus f of x divided by h is going to be 1 over 4x plus 4. I'm just going to leave it factored for right now. 4 times x plus h minus 1 over 4x. All this is getting divided by h. I'm going to write it that way because we're going to have fractions divided by fractions in a second. I'm going to make a common denominator here where I'm going to multiply by x over x here, and I'm going to multiply by x plus h over x plus h here. And this is going to give me x minus h over 4x x plus h times 1 over h. X minus x is 0, so this is a negative h over 4 x times x plus h times 1 over h. H cancels out with h, and I get a negative 1 over 4x times x plus h. On to number 29. By the way, these difference quotients, very, 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 very important. They're one of the most calculus-y things you're going to do in pre-calculus. This is right after we introduce a limit in pre-calculus. This is the foundation of what the definition of a derivative is, because you're trying to find slope at a single point in calculus class. So do not ignore this part because it looks hard. Practice this a lot. Practice doing it with rational functions like this, with polynomials. Practice it with radical functions where you have to rationalize the numerator. We talked before about that you were going to need to rationalize the numerator. This is when you're going to need to do that. All right, the graph of a function is given. Decide whether it's even, odd, or neither. So we're looking for symmetry. If we have y-axis symmetry, it's even. So remember, even functions have y-axis symmetry. Odd functions are going to have origin symmetry. So we're going to look at the graph to decide what type of symmetry this function might have. It looks like it has neither. So 29 is neither, because it doesn't reflect across the y-axis, and it doesn't reflect across the origin. Number 30 appears to have origin symmetry because every point xy seems to reflect to a point negative x, negative y. So that appears to be an odd function. Number 31 appears to be an even function that has y-axis symmetry. And that's it for that part. Now we're going to determine algebraically whether the function is even, odd, or neither. And we said that we were going to use f of negative x to do that when we talked about f of negative x earlier. So 2x to the fourth minus x squared. F of negative x is going to be 2 times negative x raised to the fourth minus negative x raised to the second. Even number of negatives is going to come back to be positive, and even number of negatives is going to come back to be positive. F of negative x is equal to my original f of x, so it's an even function. Number 33, f of x is equal to 3x to the third plus 4. So f of negative x is going to be 3 times negative x to the third plus 4 is going to be 3 times negative x to the third plus 4 is a negative 3x to the third plus 4. That's not the original, so it's not even. I'm going to try and factor out a negative 1. X to the third minus 4. This is not the original, so it's not odd. So it's neither. Now we're going to try number 34. 34 is f of x is equal to x over x squared minus 5. So f of negative x is going to be a negative x over negative x quantity squared minus 5. Negative x over x squared minus 5. I can pull that negative 1 out front, and this becomes the opposite of my original f of x, which means that this is an odd function. I'm going to tell you some fun things right now that are usually not in your textbook. The even and odd functions follow the same sign rules for multiplication and division that you're used to. Remember that if I had a and b, that ab or a divided by b. If I have two positives, this is a positive. If I have a positive and a negative, these are negatives, or a negative and a positive, these are negatives. And if I have a negative and a negative, these are positives. Remember that? Well, replace every positive with an even and every negative with an odd, and you have a sign chart of sorts for even and odd functions, because remember, f of negative x is equal to a positive f of x in the even, and f of negative x is equal to a negative f of x is an odd. See how the signs are positive and negative there? And so all I need to care about is the sign. So if I have a function f and a function g, then f g of x or f divided by g of x, those compositions, whether they're even or odd, if this is an even function and an even function, these will be even. If I have an even function and an odd function, these will be odd. If I have an odd and an even, these will be odd. And if I have an odd and an odd, these will be even. Sorry that I'm writing on a slant there, but you get the idea of how these are related concepts. It's probably not in your pre-calculus textbook or in your calculus textbook. That's just free information that I'll give you that I figured out over the years. So now we're going to graph some piecewise defined functions. F of x is equal to negative x plus 3 if x is less than 2, and 2x minus 3 if x is greater than or equal to 2. So we're going to start with x equal to 2. Negative 2 plus 3 is a 1. You need an open circle there. We need a slope of negative 1, and we're going to the left. So we need to go left 1 and up 1. And we're going to have a y-intercept of 3 here. So that's going to be this line. It's going to go all the way to the left. Then we're going to start again at 2, and we have a solid dot that's going to be here because this part is included. So 2 times 2 is 4. 4 minus 3 is 1 again. So we're going to fill in this dot. Now we have a slope of 2, so we're going to go up 2 and right 1. And like that. That's our piecewise defined function. Now we're going to have some pieces that aren't linear. So I'm going to do this again. We're going to have first piece is negative x plus 2 when x is less than 0. That's not bad, that's linear. But now we have the square root of x plus 3 when x is greater than or equal to 0. So when x is 0, we're going to have a not included y-intercept of 2. We have a slope of negative 1 again. So that's 1 left, 1 up. It's going to go this way. And then we have, this is a really bad looking 3, I'm sorry. When x is 0, y is 3. Then we have the square root of 1 is 1. 1 plus 3 is 4. And then we would have to go out to another perfect square, 2, 3, 4. Square root of 4 is 2. 2 plus 3 is 5. You start to get the curvature that comes from a square root function. Make sure you learn those parent graphs of what the, from your library functions of what the different families of functions look like. Graph of a function, y equals f of x is given below. Sketch the graph of y equals the absolute value of f of x. So anything that's negative is going to become positive is what they want you to do here. I see that if we have the point negative 4, 2 over here, and this was, we're going to have the point 4, 2 over here. We want this to have y-axis symmetry. When we're done, 4, 2, and we're going to get an absolute value function here is what we're going to get when we take the absolute value of f of x here. So there we go. Now we're going to have the graph at 0, negative 4. It's going to become 0, 4. It's going to come down to this x-intercept and down to this x-intercept. And then it's going to turn back around and go up. It's going to turn back around and go up like this. We're going to have y-axis symmetry again, but we just need to take this little piece that's negative and flip it across the x-axis so that it goes like this and keep the rest of it the same there. So okay. That's not going to be a smooth transition there at the x-intercepts. Those are going to be sharp points or cusps. Sorry if I drew it a little too smooth. Find the required composition of functions. So this one says f of x is equal to 4 over x minus 3. G of x equals 8 over 3x, and they want us to find f of g of x, which is the same thing as f of g of x, where g is the inner function and f is the outer function. So I write down f. I'm going to leave a space for the input, and the input is going to be g. Now we're going to simplify that. We need to pay attention to the fact that x can't be equal to 0 because that's the domain of g. So we may be changing the form of this, so we need to keep that original domain. So we're going to say this is going to be, let's multiply everything by 3x here to get rid of this complex fraction. That's going to be 12x over 8 minus 9x. But we have to keep the original x cannot be equal to 0. You see that it disappeared. It doesn't look like that's part of the domain. It doesn't look like that's going to give me 0 in the denominator, but it would have not given me a valid input, and I wouldn't have had a number to calculate out of this if x was 0. So I've got to write that off to the side. All right. Now we want to find two functions f and g such that h of x is the composition of f and g. So h of x is equal to 1 over x squared minus 8. The easiest way to do that is to say that f of x is 1 over x and g of x is equal to x squared minus 8, because we're just going to be sticking g into the x there. There are other ways you could find out where that would work, but this is just the simplest way to look at it. Number 41, h of x is going to be 2 over the square root of 10x plus 1. Again, we would probably want to say that f of x is equal to 2 over x and g of x is equal to root 10x plus 1. Just let g of x be the ugly thing that you're sticking in place of an x, and f of x be the other part that is nice. 43, we have g of, sorry, I'm not there yet. I need to do 42 first. 42, find the vertical asymptotes of the rational function. H of x is x plus 8 over x squared plus 4. Vertical asymptotes are going to come from where the denominator is 0, and it's not also a 0 at the numerator. We have no zeros in the denominator, so there are no vertical asymptotes. For this graph, it's going to have a horizontal asymptote at 0 here. It's going to have a y-intercept of 2. It's kind of going to look like a bell shape like that. It's going to get close to that horizontal asymptote, but it's never going to have a vertical asymptote. Okay, on to 43. G of x is equal to x over x cubed minus 27. That's going to be x over x minus 3 times x squared plus 3x plus 9. This has no real zeros to it, so don't worry about that part. I have a vertical asymptote at x equals 3 from that first factor. And I have f of x is equal to negative x squared plus 16 over x squared plus 5x plus 4. Let's factor everything here to make absolutely sure that we don't get holes somewhere. It's plus 4x minus 4. And this is x plus 1 times x plus 4. Ooh, look at that. There's a hole at x equals -4. We'll come back to that in just a second. It didn't ask us about it, but we'll talk about that in a second. We've got vertical asymptotes at x equals -1. Now at x equals -4, if we would stick that in, we're going to get -8 over -3. So there's a hole at -4 and then +8/3. For the negative divided by a negative is a positive. We need to be able, when we find vertical asymptotes, to, oops, I'm sorry, there's another negative in the problem. So that's a -8/3. And negative is a negative. So we're going to have -4, -8/3, but we need to be able to find holes, and vertical asymptotes are both excluded from our domain. All right. Find the vertical asymptotes, if any, on this function. That looks like there's a vertical asymptote right there at x equals 4. That's just that dotted line on the graph. So just being able to read the graph, they're not going to show up on your calculator most of the time unless you have a TI-84 plus something that can draw them. But most of the time those asymptotes are not drawn. We have to draw them by hand. It looks like in 46 that we have x equals -1 as an asymptote, and it looks like x equals +1 is an asymptote. So those are our vertical asymptotes. It didn't say anything about horizontal, right? Nope, just the vertical asymptotes. All right. Now we're going to find the y-intercept of the graph here. Can't have a y-intercept where there's a hole, so we're going to try and get rid of any holes first. X minus 2 times x squared plus 2x plus 4 over x minus 2, x plus 2. So f of x is going to be equal to x squared plus 2x plus 4 over x plus 2, as long as x is not equal to 2. Then we're going to find the y-intercept. That's going to be when x is going to be equal to 0. We're going to find that as 4 over 2 is 2. So 0, 2 is my y-intercept. I could have done that from all the way up here, just stuck it in and gotten -8 over -4 is also 2. Just watch out for holes. You don't want to have something that you think is a point that is a hole. Now we want to find the y-intercept of f of x is equal to x over x plus 9 over x. We have none. No y-intercept, because if we try and stick in f of 0, 0 plus 9 over 0 is what we would think. This is undefined. So there's a vertical asymptote there. At x equals 0, we can't have any points on the vertical asymptote. 49, let's find the x-intercept of f of x is equal to 2x plus 9 over x minus 8. So my x-intercept is going to come from when my numerator is 0. 2x is equal to a -9. X is equal to -9 over 2. The x-intercept is going to be a point like that. Same thing with the y-intercepts when I found them. Graph the function. F of x is equal to x squared plus x minus 12 over x squared minus x minus 6. We're going to factor. This is x plus 4 times x minus 3 over x minus 3 times x plus 2. X minus 3 is going to cancel, which means we have a whole at x equals 3. We'll get to that in just a second. F of x is equal to x plus 4 over x plus 2. As long as x is not equal to 3, there's a hole there. So we're going to have a vertical asymptote at x equals -2. We're going to have a horizontal asymptote at y is equal to 1 because the degree at the top is the degree of the bottom. We're going to have a y-intercept of 4 divided by 2 is 2. We're going to have an x-intercept of -4. I don't think that it's ever going to cross. No, it will never cross this, this horizontal asymptote, but let me prove that to you. I'm going to set it equal, and then we're going to cross multiply. We're going to prove that 4 is never equal to 2. There's no x values that make that true, so it's never going to cross. So now I've got to stick this hole in the graph, 1, 2, 3. And when I do, that is 7/5. So that's 1 2/5. 1 2/5 is, just call it around there somewhere. So it's coming down here, getting close. And then it's coming up here, getting close. This is coming down this way, getting close, crossing, and coming over here, getting close from the bottom. All right. That is my sketch of number 51. Now, for this function, f of x equals 9x, they want me to find f of x minus f of 1 over x minus 1. This is a different kind of difference quotient here. It's the same idea as a difference quotient though. 9x minus, if I find f of 1 is 9. 9 over x minus 1. X is not equal to 1, and I should always get this x minus 1 to cancel. It should be a factor at the top. This denominator should be going away. This is 9. It should not surprise me that the slope here is 9 because the slope of this function was 9, right? So there we go. 53, f of x is equal to the square root of 2x minus 1. Now we want to find an average rate of change on the interval from 1 to 5. So we're going to find f of 5 minus f of 1 over 5 minus 1. That's going to be square root of 9 minus square root of 1 over 5 minus 1 is going to be 3 minus 1 over 4 is 2 over 4 is 1/2. The average rate of change is the slope of the secant line. Now we're going to find the equation of the secant line containing 1 f of 1 and 2 f of 2. So this is that same idea here. So we've got f of x is going to be 8 over x plus 7, but they said they want us to find the ordered pairs here. For f of 1 is equal to 8 over 8 is going to be 1. So we've got the point 1, 1 on the line. F of 2 is going to be 8 over 9. So we've got the point 2, 8/9. These 2 points determine a line. We're going to find the slope of that, y2 minus y1 over x2 minus x1 is -1/9 over 1 is -1/9. That's my slope. Pick either point. I'm going to pick 1, 1, so I don't have any more fractions to deal with. Y minus y1 is equal to m times x minus x1. The y minus 1 is equal to -1/9 x minus 1. I'm going to write it in y equals mx plus b form. -1/9 x plus 1/9. I'm going to add 1. I'm going to add 9/9. as my form of 1, y is equal to negative 1/9 x plus 10/9, and that's the equation of my secant line. Now we're going to compute the difference quotient for these functions. More practice with difference quotients. I told you it wasn't going to go away. So f of x is going to be equal to 9x squared plus 9x. So my difference quotient, I'm just going to abbreviate that, is going to be equal to 9 times x plus h squared plus 9 times x plus h minus 9x squared minus 9x, all divided by h. H can't be 0. So this is going to be 9 times x squared plus 2xh plus h squared plus 9x plus 9h minus 9x squared minus 9x over h. H can't be 0. This is 9x squared plus 18xh plus 9h squared plus 9x plus 9h minus 9x squared minus 9x over h, and h can't be 0. So we're going to get rid of the parts that don't have h in them. It's going to be 18xh plus 9h squared plus 9h over h. H can't be 0. We're going to factor that common factor of h out of the numerator. 18x plus 9h plus 9 over h. Since h can't be 0, I'm allowed to cancel 18x plus 9h plus 9. We're just one step away from a calculus problem there, so that you understand that. Now we're going to do f of x is equal to x minus 10 over x plus 3. So we're going to find the difference quotient here is going to be f of x plus h minus the original f of x, all divided by h. So this is going to be we're going to make a common denominator first. So this is x plus h minus 10 times x plus 3 minus x minus 10 times x plus h plus 3 over x plus 3, x plus h plus 3. And then I'm going to go ahead and say times h. H is going to go into the denominator down there because I'm multiplying by 1 over h. So now we're going to need to do a lot of distribution here. X times x is x squared. X times 3 is 3x. H times x is hx. H times 3 is 3h. Negative 10 times x is negative 10x. Negative 10 times 3 is negative 30. Minus x times x is x squared plus xh plus 3x. Zoom out a little bit. Minus 10x minus 10h minus 30 all over x plus 3, x plus h plus 3 times h. Remember, h can't be 0 here. So x squared minus x squared is 0. Hx minus xh, same thing. 0. 3x minus 3x is 0. Negative 10x minus negative 10x is 0. Negative 30 minus a negative 30 is 0. And I end up with 3h plus 10h over x plus 3 times x plus h plus 3 times h, with h not equal to 0. So I have only the h terms left. That's going to give me 13h over x plus 3 times x plus h plus 3 times h. Since h is not 0, we can cancel there. And we get a final answer for our difference quotient of 13 over x plus 3 times x plus h plus 3. That was exciting. All right. Now we're going to solve some systems of equations. The first one they want us to solve by substitution. X plus 7y equals -2. 3x plus y is equal to 34. It matters not whether you solve for x in the first one or solve for y in the second one. Whichever one is easier for you. They both have coefficients of 1. I'm going to solve for x in the first one. So x is equal to -7y minus 2. I'm going to make that substitution into the second one. And that's going to give me -21y minus 6 plus y is equal to 34. So -20y minus 6 is equal to 34. I'm going to add 6 to both sides. -20y is equal to 40. So y is equal to -2. I'm going to come back to the first equation up here and say x is going to be equal to -7 times a -2 minus 2. X is going to be 14 minus 2. X is going to be 12. Check it, make sure that it works in both. It should. 12, -2. So 12 minus 14 is -2. 36 minus 2 is 34. 12, -2 is my solution. Now we're going to use the elimination method or the addition method. 6x plus 21y is equal to 21. 5x minus 7y is equal to -7. The reason we're using the addition or elimination method here is because we don't have any coefficients of 1, but we do see that we have opposite signs on our y's and that 7 is easily multiplied by 3 to get 21. So I'm going to multiply the second equation by 3. 15x minus 21y is equal to -21. 6x plus 21y is equal to 21. We're going to add, we're going to get 21x is equal to 0. X is equal to 0. Come back to either equation, doesn't matter. I'm going to pick the second equation. 0 minus 7y is equal to -7. -7y is equal to -7. Y is equal to 1. So if I have 0, 1 as my solution here, 0 plus 21 is 21. 0 minus 7 is -7. So that's right, it's 0, 1. Now we're going to solve the system of equations, but there's 3 equations now. 3 equations with 3 unknowns. X plus y plus z is equal to 1. X minus y plus 4z is equal to 26. 5x plus y plus z is equal to 5. Now you may have learned how to do this on your calculator. You may not have. I assume that your teacher is going to let you use your calculator at this point, not make you do a 3 by 3 by hand. So I'm going to show you how to do it with a calculator. Maybe you learned this, maybe you didn't. We're going to go into our matrix menu. We're going to edit, and we have 3 rows and we have 4 columns. So 3 by 4. You could have used this with all of the other systems of equations as well. We just typically only use it when it's 3 equations, 3 unknowns or bigger. I'm putting in my coefficients and my constants from the right-hand side. Everything needs to be lined up in columns like it is right now before you make these entries. Watch out for your signs, double check everything. Make sure you didn't skip anything. Okay, so there we have our system of equations represented as a matrix. This is an augmented matrix where the last column is is on the other side of an equal to sign. The calculator understands that because there's one more column than there is a row. I'm going to quit out of this. I'm going to go back into my matrix menu to do some math. I'm going to find the command that says RREF, which stands for reduced row echelon form, second matrix A, and this is going to solve it for me. And this is going to tell me that my solution to this is going to be X is going to be 1, Y is going to be -5, and Z is going to be 5. I just read it from right there. There's some other ways that I could solve this. You might want to look up called Cramer's rule. I might want to solve it using inverse matrices or matrix equations. I might want to just do it with elementary row operations. So I just don't think that that needs to be the emphasis of the video. If we're going to do something with linear algebra later, we'll talk much more about elementary row operations and all of these other ways to solve matrices. But if you have a 3x3, feel comfortable with sticking it in your calculator to get an answer unless your teacher tells you differently. So let me go ahead and hide my calculator for right now. On to number 60. We're going to solve this by substitution. X squared plus y squared is equal to 13. X plus y is equal to 5. So I'm going to go ahead and there's no, I'm not going to solve and get a square root. What I'm going to do is I'm going to square both sides of this second equation. I'm going to get x squared plus y squared plus 2xy is equal to 25, which means x squared plus y squared is equal to 25 minus 2xy. And I'm going to replace the x squared plus y squared on the left-hand side with 25 minus 2xy is going to be equal to 13. Now I'm going to come back and I'm going to say that means that negative 2xy is going to be equal to a negative 12, which means xy is going to be equal to 6, and y is going to be equal to 6 over x. I come back and make a substitution back here. X plus 6 over x is equal to 5. I'm going to multiply everything by x. X squared plus 6 is equal to 5x. X squared minus 5x plus 6 is equal to 0. X minus 2 times x minus 3 is equal to 0. X equals 2 or x equals 3. So then I'm going to come back to y here and say if x is equal to 2, then 6 divided by 2 is going to be 3. If x is equal to 3, then 6 divided by 3 is going to be 2. So those should be my solutions. Let's go ahead and check them out. 4 plus 9 is 13. 9 plus 4 is 13. 2 plus 3 is 5. 3 plus 2 is 5. These are my two solutions right here. Number 61. Supposed to solve this again by substitution. Y equals x squared minus 13. X squared plus y squared is equal to 25. So we're going to take this y and we're going to plug it in for the y right there. X squared minus 13. This is x squared plus x to the 4th minus 26x squared plus 169 is equal to 25. So this is x to the 4th minus 25x squared is equal to, subtract 25 here. So this is plus 144 is equal to 0. Okay, so this is a quadratic in terms of x squared. It's not a perfect square trinomial. Do I have factors of 144 that add up to give me negative 25? I don't think so, but let's check that out. Factors of 144, 1 and 144, 2 and 72, 3 and 48, 4 and 36, 6 and 24, not 7, 8 and 18. That adds to be 26. I'm real close. 9 and 16 add together to be 25. That's it. So this is going to be x squared minus 9 times x squared minus 16. So this is x plus 3 times x minus 3, x plus 4, x minus 4. So x is equal to -3, or x is equal to 3, or x is equal to -4, or x is equal to 4. So that means that I want to zoom out a little bit so you can see everything here. So if x is -3, then that means that y is going to have to be 9 minus 13 is a -4. If x is 3, also going to have a -4. X is -4, that's 16 minus 13 is 3. X is 4, also going to have 3. 9 and 16 is 25. 9 and 16 is 25. 16 and 9 is 25. 16 and 9 is 25. All of these work in all of these work in both equations. So I have 4 solutions to those equations. So what I had, so that you understand, is that I had a circle of radius 5, and I had a quadratic equation that came down and intersected at 1, 2, 3, 4 times. And that there's symmetry here so that I have points that are -4, 3, 4, 3, -3, -4, 3, -4. Okay. That's what it looked like. Ooh, now we have some fun stuff with some natural logs. Natural log of x is equal to 3. Natural log of y. 3 to the x is equal to 27. It's 27y, not 27 raised to the y. That's 27y because the y is not little. So, okay, this is going to be, for this first equation, is ln of x is equal to ln of y to the third. So x is equal to y to the third. So I can come back and say, 3 y to the third is equal to I'm sure that's not to the y power. Let me zoom in on that. Now that's all on the same level. Is equal to 27. I'm almost certain that's supposed to be to the y power, because I don't think I can solve this without this. Okay. It's going to be like this. It's going to be 3 to the third to the y power. So that's going to be 3 to the 3y is going to be y to the third is equal to 3y. Then I'm going to subtract y equals 0, or y equals negative root 3, or y equals root 3. Then I can come back and I can say, well, if I'm looking at my original equation here, where I have an ln of y in it, I'm not allowed to have a 0 inside of an ln. I'm not allowed to have a negative inside of an ln. So my only possible answer to this is going to be when y equals the square root, when y equals the square root of 3, then x is going to be equal to the square root of 3 cubed is 3 root 3. So I need to go back and make that worksheet clear and make sure that that says 27 to the y power. Okay. Number 63, this is our last one for today. X squared plus y squared is equal to 40. X squared minus y squared is equal to negative 32. So we're going to use addition here because we can do that. 2x squared is equal to 8. X squared is equal to 4. X equals negative 2 or x equals 2. There's no advantage to using one over the other here. I'm going to go ahead and use the first equation. I have 4 plus y squared is equal to 40. That's what I'm going to get either way when I square this, because x squared is 4. Y squared is equal to 36. Y equals negative 6 or y equals 6. So I'm going to get the ordered pairs as solutions. Negative 2, negative 6, negative 2, 6, 2, negative 6, and 2, 6. These are my ordered pairs that are solutions. 4 plus 36 is 40. 4 minus 36 is negative 32. All of those give me that. That is it for our pre-calculus part 1 review. Next video, we will go over some trigonometry stuff from pre-calculus part 2. And that will be the end of our prerequisite review for calculus 1 with analytic geometry. See you in the next video.